Hello and welcome to this video on R. R is the open source statistical package of choice. Well, it is more accurate to call it the programming language of choice. However, as far as programming languages go, it is only used in the R program, so it doesn't really derive anything else. When conducting statistical tests, you originally had to do everything by hand or close enough. This was tedious and inefficient. Over time, computer scientists and programmers found ways to automate much of this work. The two big companies that produced commercial software were SPSS by IBM and SAS by SAS Institute. Both of these are for-profit businesses of a sort. This means licensing fees, copyright, intellectual property, and other problems. Everything could add up very quickly. They were also somewhat handicapped by a lack of customizability in the code, packages, and so on that could be added to increase the flexibility and utility. Eventually, an alternative came about. This was R. R is an open source program, or more accurately, system that implements R as a language to conduct statistical tests and more. To better understand this, let's look at R as it is. This is a bash line interface. You might see the resemblance to the command line in Windows. This is just the only option. There is no graphical interface as it is. Everything is done from this screen. Fortunately, another package exists called RStudio. This builds on and adds a graphical interface to R. Otherwise, the basics between this and R do not change. It still uses the same underlying code, languages, commands, and more. It really is just a matter of you getting a nicer user interface to interact with R, and some buttons that will streamline processes that would otherwise have required you to type in code beforehand. We'll be using RStudio for the B-roll of this video from here on out, but it's worth noting that there is a change and why that change occurs. It makes it a much more user-friendly scenario. The first release of R was in 1991 and it was largely for academics and statisticians in the know. It was later available publicly in 1995. This was supported by a repository called the Comprehensive R Archive Network, or CRAN. CRAN is important as it contains a huge bank of files, code, and documentation. Remembering, this is open source. These files can be added to, which will be important later on. CRAN is further supported and mirrored by hundreds of government and private universities that allow you to download that code and the base files for R from them for free. Where R differs from SPSS and SAS in the first place is how it is free open source statistical package. You can use it and not pay a license fee. There are some limited caveats, but they'll not be discussed here. However, when you go to download R, you will see different licensing agreements. R lets you run your normal statistical tests, correlation, significance, chi-square, ANOVA, linear graphing, and so on. It lets you plot or graph your data and the derived results. It also lets you directly edit your raw data. All of this is without ever leaving the program. This is great for things like generating plots, graphs, and more, identifying missing data, checking normality, and further. There is a great amount of flexibility, efficiency, and power in a free program without spyware, a cryptocurrency miner, or giving your computer venereal disease. Considering everything we've said so far, you might think that we're biased, but there are going to be downsides to R. In fact, there are several. The biggest is that it is very procedural. That is, you must type out instructions to do many of the steps that are otherwise automated in programs like SAS and SPSS, unless you very clearly provide instructions to R to handle your data in a particular way and do certain things that are otherwise automated in other programs. It will only do what you have told it to do, and your attempt may fail on that basis. R is also very dependent on the user to type out instructions and know the language, how to direct paths to files, how to call on data in a spreadsheet, and more. Admittedly, many of these commands that you can call on in R can also be called on for an explanation of what a function does, so it's not as though you are left absolutely high and dry. If you don't know what something does, you can very quickly and very easily find out from R itself what that function does. This means that although you need to know to use it, you can find out what it does. You can figure out how to attribute certain variables, create groups, create variables, and more. We already mentioned this, but it is worth reiterating. R can be expanded with packages. These can add tests, plots, and more functions. Do you need to use data and place it on a map of the world, a town, or even a very narrow geographical region? You can do all of this in R, using packages that expand its utility beyond just the original scope of the initial downloaded package. Do you want a heat map of prevalence? Generate datasets by scraping the internet, and document your entire process? R can do that. Many of the packages are just something you can add directly from R's repository without ever having to go to a shady website. It also comes with most everyday packages you will need in the original base program. The repository includes ways to add functions and use more specific functions, tests, and other things. You don't need to pay extra licenses, buy add-on packages, and more that would be common with other statistical programs. You often don't need to build your own particular package. Many things are available, already made by the community and are available to use, or you can find ways to type out the code within R to pull them down from the place where they are otherwise held. This frees up a lot of time and resources, and means R is very much community driven. R is a powerful free tool that lets you conduct more than less all of the same functionalities of the licensed, fee-driven statistical tools out there, but it appears to have more flexibility without the cost. You will need to learn how to use R, but it is a skill set that will not go to waste. It often includes logical thinking, how to program, and similar skill sets. For those who are already familiar with programming languages such as Python, this is especially a small step. There are no huge leaps, but there are some quirks in the way certain symbols are used. It has other benefits that SPSS and SAS do not provide. On the other side of that equation though, when you are paying for a program like SPSS or SAS, you often get a lot of specialized technical support that isn't available in R, and many times you have to do a lot of your own troubleshooting, which again develops the necessary skills and thinking, critical thinking especially, to proof your own work and find solutions to something you've created. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.